Show that the following number is rational by writing it as a fraction of integers. 5.013590590590590 dot dot dot. So I assume that means that the 590 repeats forever. Okay, well, it's got a repeating bit at the end, so it certainly can be written as a fraction because I know that rational numbers can, any repeating decimal is always a rational number. And I know that writing as a fraction makes it a rational number because that's the definition of rational. A number is rational if you can write it as a fraction of integers. So I just need to figure out what that number is. So, well, it's the repeating bit that's the problem, isn't it? If I could get rid of the repeating bit, I'd be good. So, what could I do? If I could just shift it up a bit, subtract something with the same repeating bit, the repeating bit would disappear. I can't just think of some other random number with the same repeating bit because I don't think that would really help me because I'd need to know what that number was as a fraction. But if I could do it in terms of this number, maybe I could figure it out. Anyway, I think I'll do what the standard trick in all of mathematics, which is just to let the thing I've got be x until I know what to do with it. So let's say let x be equal to 5.013590590 and so on. Okay, so if I could shift it up so that I had a number with 590,590 dot 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 here, then I could subtract it off and that would get rid of the repeating bit. So, well, if I multiplied it by enough tens or hundreds or something, I could shift the whole number forwards. So if I multiplied it by 1,000, that would shift it forward 3 places. So 1000x would be equal to 5013.590,590,590, and then I could subtract the top equation from the bottom equation. So 1,000 minus 1, 1,000x minus 1x would be 999x. 5,013 minus 5 would be 5,008. 0.590 minus 0.013 would be 0.577. And then the 590, 590, they'd all cancel out. So now I've got a much better number to deal with. So certainly x is equal to 5008.577 over 999. But I haven't written it as a fraction of integers yet because that top number has a decimal point in it. So if I can multiply top and bottom by the same thing, by 1,000, that ought to do it. So 5008,577 over 999,000. And so I've written my number x as a fraction of integers. So therefore, x is rational. And I'm done.